Hi guys, welcome back to another honors geometry video. It's Miss Warren here. In this video, we are going to be doing a review of solving for missing parts of similar right triangles. Okay, so you have learned this skill already. You had another video on it that was a little more extensive and we had class, but this is truly just solidify and make sure that you have this super solid. So we're only going to go through a couple examples. It shouldn't be super long. I say that now, but I talk a lot. So hopefully you get something out of it. In this first example here, we have one large right triangle, and within that right triangle, the altitude makes two other right triangles. So we have a total of three right triangles, and we've already learned that these triangles will be similar by angle, because each of them has a right angle, right? And then we're also going to know, I'm just going to pick an angle, let's say here, right? If I have an angle there, that angle is shared between two triangles. It's shared between the larger triangle as well as the triangle with sides y, z, and 20. Right? And then that same triangle will have to have some other measure here. Right? Because the larger triangle has a 90 here and this angle here, the larger triangle is also going to have an angle that's the same as that angle right there. Okay? And that means that other smaller triangle here that has that right angle, the angle that matches with this angle, they're also going to have an angle that matches with this angle. Okay. Probably could have made that simpler by like naming them or giving measures or something, but hopefully that made sense. So what we're going to do, just like we did in class, is I'm going to draw out all of these triangles with the same orientation. So I'm going to keep the largest triangle as is. I'm just going to draw that out again. I'm going to, that doesn't look great. I'm going to start over. Okay. So we have 15, 20, so I'm going to make it a little longer, and then we have the hypotenuse. Obviously, it doesn't have to be quite to scale, but I like to distinguish the short and the long side. Okay. So I draw out that right triangle, and then I have this side of 15. I have this side of 20, and then the hypotenuse, well, that's not just made up of one variable, it actually is part x and part y, so the hypotenuse is actually going to be x plus y. No problem, we can still find x and y. Next, I'm going to draw out this smallest triangle. Doesn't matter what order we work in, but I just want to do that next. So I'm going to draw another triangle, a similar triangle. And I'm really purposefully making this vertical side the shorter side and the horizontal side the longer side, because the way I like to orient my triangles, the way I think about it when I'm drawing them separated, is that I think about what is the short side, what is the long side, and what is the hypotenuse. Personally, not as much of a visual person, thinking about rotating and reflecting the shapes in the air to try to match the positions. That's not really my style. So I like to just think, what's the long side, what's the short side, what's the hypotenuse? And then I go back and double check at the end to make sure I'm right, and I'll show you that as well. But basically, so I'm looking at the smallest triangle, the one to the left, and I'm thinking, what's the shortest side? Well, x. What's the long side? When I say side, I mean the legs. So what's the shortest leg? Then what's the longer leg? Right, the longer leg is z, and then you can see the hypotenuse on that is 15. Right? And then I'm going to follow the same thought process with the medium-sized triangle, so the triangle that is to the right side. And again, I'm going to draw short side, long leg, hypotenuse. Looks like the shorter side of that triangle is z, the longer leg is y, and the hypotenuse is 20. So at this point, I said once I did short side, long side, hypotenuse, I like to double check. That's just, I guess, in case visually something isn't working out with short and long side, you picked the wrong one or something. So we're going to go back through and make sure that these match by making sure that I have all the congruent angles in the same positions. So what I'm going to do is I'm going to look at this big triangle. And right here, I had this angle here marked with 2 arcs. So I know that that angle where I drew the large triangle has 2 arcs. And in the bottom right corner, again, I didn't change the orientation here, so that has 1 arc. For the other 2 triangles, in order to figure out where those arcs match up, what I'm going to do is I'm going to look in this small triangle, what is between x and 15. How many arcs do I draw between x and 15? So if I find 15 and I find x, I can see I have 2 arcs drawn between those. So at the angle between those two sides, that's 2 arcs, right? And just by finding that much, that tells me I'm correct because we know that they're similar. So if that one is correct, I know that this has just 1 arc. I'm going to do the same thing with the last triangle. I'm just going to look between z and 20. So this side is z, this side is 20. Oh, the angle in between them is marked with 2 arcs. I'm literally making a mess of this drawing, but again, hopefully you get the picture. And if that is marked with 2 arcs, the other angle must have 1 arc. I mean, you can totally double check that too. Like, what is between 20 and y? Oh, here's 20, here's y. Yeah, the angle in between is just that singular arc. Okay. And as you can see now, I have all these 3 triangles. The angle at the top of each has 2 arcs, and to the right has 1 arc, which means that they all are oriented correctly. From here, it's time to get solving, right? There is not necessarily one specific order you can work in. Depending on the problem, you might be able to start with different pieces. What we tend to look for is there one triangle where I know 2 of the side lengths, so I can use the Pythagorean theorem to find the last length, okay? Or you could start by finding something else by setting up a proportion, but I kind of like to just find one whole triangle first. So that's what I'm going to do. I'm going to work with this first triangle to the left because that's the only one where I have 2 side lengths. One is 15, one is 20. I want to find the third side. Now, if you know your Pythagorean triples really well, you probably already know what that length is. I could tell you that without doing the math because I know my Pythagorean triples. But if you don't know your Pythagorean triples off the top of your head, you can always plug these numbers in the Pythagorean theorem, right? So a squared plus b squared equals c squared. Your legs are a and b, so 15 plus 20 squared. And I'm just going to say that equals c squared because I don't want to deal with writing x plus y squared. It's going to be a lot of writing. So we're going to stick to the a, b, and c from the Pythagorean theorem. Right. When I go from there, I'm going to take 15 squared, which is 225. I'm going to take 20 squared. I forgot to write the squared. Okay. 20 squared, which is 400. And say that is equal to c squared. Okay. I add 225 plus 400, get 625. And I take the square root of both sides. And I find that c is 25. Okay. And what that indicates to me is the last side of this triangle is 25. Okay. So x plus y is 25. Honestly, we weren't looking for x plus y, we're looking for x, y, and z, so maybe that wasn't the smartest way to start the problem, but sure, it doesn't hurt anything to have that value for that triangle. Okay. What I'm going to do next is I'm going to start using proportions. Okay. So I have 3 values from this first triangle, and both the other triangles have at least 1 value there, so we can start looking. So I'm going to just solve for x next, I think. So I'm going to need to use the side of 15 and this side with x. Okay. Remember that I don't want to have 2 variables in my proportion, so I'm going to use one side that has the number already there, the side length. So I'm using x plus 15. I can compare that with 15 and 25. So what I'm going to do is I'm going to say that 25 divided by 15 is equal to 15 divided by x. Right? So the hypotenuse divided by the short leg for both of these. And then I use cross multiplication, right? If I multiply 25 by x and 15 by 15, I end up with 25 is equal to 25x. I wrote that wrong. 25x equals 225. And then from there, I divide both sides by 25, and x equals 9. Again, if you know your Pythagorean triples at this point, you probably know your value for a z. But if you know your Pythagorean triples, use some other method. We already practiced the Pythagorean theorem once. That was good practice. Let's use a proportion this time. So this time I'm going to use short leg and long leg. So 15 and 20 and x and z. But x, I now know, is 9. So 15 divided by 20 equals 9 divided by z. Again, with cross multiplication, I'll get 15z is equal to 9 times 20, that would be 180. Okay, divide both sides by 15, and I would get 12. Okay. Awesome. Last thing we need to look for is y, as this page is getting wildly messy. We're going to draw a box for it to kind of keep it separate. Again, many choices to work with here. I'm thinking I'm just going to go with the short side and the long side, 9 and 12 from here. And then 12 and y. Again, short side to long side. Cross multiply. That gives me 9y. Oh man, this pen. Distance learning, man. That's fine, I'll just use my trackpad. 9y equals 144. Honestly, my handwriting's probably better when I do this instead of the touchscreen. If I divide both sides by 9, right, divide by 9, I'm going to get 16. I tried to use my touchscreen again. It's obviously not working out for me. Equals 16. And then I have found x, y, and z. Yay! So again, these problems, they take a little bit longer because they're a lot more work, but you are sort of repeating the same skill over and over. So once you learn how to set up one proportion, really you should be able to work through the entire problem just the same. You're repeating the process over and over. So what you need to know is Pythagorean theorem and proportions. Okay. Now we're going to move on to another problem. This is the last one we're going to do. We're only doing 2 today. And again, looky here, I have a larger right triangle with 2 smaller ones inside, and I'm going to start by drawing out all those triangles again. So I am going to start, I don't want to use red this time, let's use blue. Okay, I'm going to start by drawing this largest triangle, and again, I'm just going to orient it like this because I think that's easiest. Oh, and again, I like to sort of emphasize which is the short side and which is the long side and make that really obvious, which is why I'm about to redraw this. So let's go short side, long side, hypotenuse. Okay, so of the largest triangle, shorter side is z, okay, the longer side is y, and the hypotenuse is 3 plus x. Okay, then I'm going to do the smallest triangle. Again, I'm going to draw it the same on the page, not drawn to scale. But what I am going to say is, what is the smaller side? So what's the smallest side of this little triangle here? And the shortest side is 3. So short side is 3. The longer of the legs, right, is 6. And the hypotenuse is z. Okay. And then I'm going to work with my last triangle. So again, short side, long side, hypotenuse. So the short side of this triangle here is going to be 6. The longer leg is going to be x, and the hypotenuse is going to be y. Then clear up that drawing so it doesn't get as messy as last time. All right. Next step, we're just going to check to make sure we have all those oriented correctly because we like to check our work as we go. And we're just going to play around with the angles. So basically, you're just going to pick one angle. Let's say this angle, and put one arc through it. Okay. You know the other triangle in here is going to have 2 arcs through it. So now that triangle has my arcs marked. Now I just have to mark the smaller triangle accordingly. I know that this angle here has to be the 2 arcs, right? Because it's not going to be congruent to this because the larger triangle needs one of its angles to be 1 arc and one of its angles to be 2 arcs. So I have a right angle, a 1 arc, and a 2 arc in the largest triangle. I have in the one I started with, and then I'm just going to add this singular arc right here for my smallest triangle. And again, I'm just going through and double checking that the positioning is right for all of these. So you can see that I have this 1 arc here for the biggest triangle between the y and the side that becomes x plus 3. So between y and x plus 3 is 1 arc. And then by definition, this other one is going to be 2 arcs. Okay. For the next triangle, I'm just going to see is the side between Z and 6, is that going to be 1 arc? So between Z and 6, well, where those connect was in fact 1 arc, so we look good to go here, right? That means we have a triangle like that. And then I also want to double check that between Y and X is 1 arc, and yep, between Y and X, the angle that connects those sides is 1 arc. So all of these are similar. We are good to go. We checked our work. So we know that we're going to be able to set these proportions up correctly. I like to go in super confident that I set it up correctly because these are really long problems to make a problem early on and not notice it until later. So just go ahead and double check that work right away. I think that's for the best. Okay. Now I'm going to go ahead and start solving up problems. Let me take a minute, see what makes sense to solve for. Okay. Couple options. We could start with the Pythagorean theorem on that middle triangle, right? To get all 3 sides there. You could start with a proportion if you want, because you do have this middle triangle has 2 side lengths, and then this one to the right, you know, 1 of the side lengths. So I think that's the route I'm going to go this time. Again, there's no right or wrong answer. You could start with the Pythagorean theorem and solve for Z first, but I'm just personally going to solve for X first. So I'm going to take the ratio. Again, I feel like I'm using the 2 legs for both these triangles. I'm just going to go short side to long side. So I'm going to say 3/6 for that middle side is going to equal 6x from the other triangle. We're going to cross multiply. So 6 times 6 gives me 36. 3 times x gives me 3x. Okay. And then from there, since you have 3 times x, I'm going to divide both sides by 3. And if I divide both sides by 3 on that left side, I end up with 12. And we know that those 3's would cancel because 3 divided by 3 is 1. So I find that x is equal to 12. Okay, so let's figure out what we want to do next. I don't really want to work with that for this left triangle at all because I'm looking at my 3 sides and one is 3 plus x, one is z, and one is y, right? So I don't have any sides on that triangle that are just like a plain old number. I'm not really given any side length. Makes it a little more complicated to work with. So we're just not going to go down that path. I'm going to try to find something simpler. And what you can actually see is we've already found x. So I guess technically you could actually know the length of that hypotenuse, but we might as well just find z and y from the 2 triangles I have for this to the right. Like, I think it's just going to be a little bit simpler. So I'm going to go ahead and just switch to the Pythagorean theorem real quick. And I'm going to do that just on this middle triangle right here and try to solve for z. So again, the Pythagorean theorem is a squared plus b squared equals c squared. So I have to square my 2 legs and add them together. And that's going to be equal to the hypotenuse squared, which in this case we're calling it z. Okay. 3 squared is 9, 6 squared is 36, z squared. Add them together to get 45. Okay. And from here, in order to figure out the value of z, I'm going to have to take the square root of both sides to get z isolated. And then what you're going to find is the square root of 45 isn't a whole number, right? It comes out to a infinite decimal. So if you try to type that in your calculator, you would have to round it. Again, if we ask for a rounded answer, that's how you would approach it. You type it in your calculator. There's really no other way to do it. Well, there is, but y'all probably don't know, and it would just take a long time. So you type it in your calculator, figure it out. But we're not going to do that because I want an exact answer. So we can just leave this as the square root of 45. It's in radical form. Okay. Technically, you could go further and put it in simplest radical form, but I don't think that's somewhere we're going to go this video. We'll see if I change my mind by the end of it. But anyways, now we have the value of z. It's the square root of 45. That's my exact answer for z. And so the last thing I need to find is y. Again, a couple options here. I could use the Pythagorean theorem. I could use proportions. Kind of in a Pythagorean theorem-y mood, so I'm just going to keep going with the Pythagorean theorem and go a squared plus b squared equals c squared. So my two legs are 6 and 12. So 6 squared plus 12 squared equals y squared. Okay. 6 squared equals 36. 12 squared equals 144. Add them together to get 180. Okay. And then here, again, in order to get y as just a y instead of y squared, I square root both sides. Once again, I'm left here with a radical that doesn't come out to a whole number. If you type 180, square root of 180 in your calculator, it's not going to come out as a whole number. So to leave it exact, it's going to have to be left in radical form. So I'm just going to leave it like this. And now we have found x, y, and z. Okay, and actually, maybe we are going to go back in and simplify the radicals real quick, just because I feel like it can't hurt to expose you to that as many times as possible. The higher the math class you get, the more often you're going to be expected to do it, so why not go over it right now? So for z, we have the square root of 45. And if you remember, when we want to simplify a radical, right, I want to know a number that I can factor out of the radical sign, right? So basically, I'm looking for a number that is a factor of 45 that I can actually take the square root of. So thinking perfect squares that 45 is divisible by. And when I think about those numbers, I know that I can divide 45 by 9. So that means another way to write 45 is by writing 9 times 5, right? Those are the same thing as each other, okay? But where this helps me out is the square root of 9 is a number I know. So if I split this into two radicals, square root of 9 and square root of 5, right? The square root of 9 is 3. The square root of 5, that just simply cannot be simplified any further. So in simplest radical form, that answer is 3 times the square root of 5. Okay. Again, not really what we're assessing at the moment that you know, but it's a skill you're going to need in the future. So it doesn't hurt anything. So I'm going to do it for y as well. Right? I'm looking for the largest perfect square factor of 180. So it's the largest perfect square 180 is divisible by. Now 180 is a little bit bigger of a number, so you may not know right away what all it divides by. So I'm just sort of going to go through a list of perfect squares. Again, we want the largest one that fits in. So I'm going to start with 100 and actually work through smaller. So in my mind, I'm saying, okay, 180, is it divisible by 100? No. Is it divisible by 81? No. Okay, 81 is 9 squared, 8 squared is 64. Is it divisible by 64? Again, no. Next perfect square is 49, not divisible by that. But the next perfect square is 36. And if I divide 180 by 36, that comes out to a whole number. So I actually find that because 180 divided by 36 is 5, I can rewrite 180 as the product of 5 and 36. Okay. From here, I now have two numbers under this radical symbol. One is a perfect square. So if I split this up into two separate radicals, right, I'm still multiplying them, so it's still equivalent. Right? But this allows me to take the square root of 36, which I know is 6, and then say that my answer is 6 times the square root of 5. So again, our answers before were correct. They just weren't written in simplest radical form. So the part that I just wrote in red at the very end was sort of just one step beyond in simplifying. So hopefully this video was helpful and you feel super solid now on solving these types of problems. If you still need practice, again, there are plenty of resources, supplemental resources. There's the other video to look back on. Talk to your teacher about coming for office hours or something like that. Okay, other than that, bye.